Sample exam 8, problem number 44. Let xy have a joint density function f of x y equal to 2 for x between 0 and 1. What is the variance of y given x? Number 44, we're going to do this two different ways. One is a very quick way, and then one is a little bit longer. And here, let me give a note first. If, for instance, w is distributed uniformly on the interval a to b, then its mean is a plus b over 2, and its variance is b minus a squared over 12. So that's, if you know that fact, then this becomes quick. Well, and also another fact I'm getting ready to tell you. But this is our region, and it's constant. It has so f of xy is 2. So it's a flat density over this. It's uniform. And if that's the case, then any conditional y given x or x given y is also uniform. And the boundaries are given by, what the boundaries are. If you condition on x, it means given x, then y is uniform from 1 to x. So that's this right here. Well, and the variance of a uniform is 1 minus x squared over 12. And we're done. Now, if you didn't know that fact, we have to find it. So here since we want the variance of y given x, we need the marginal of x. So we integrate out y from our joint density of 2, and we get 2 minus 2x. So that means the density of y given x is the joint, which is 2 over the marginal that we just found, and that reduces to 1 over 1 minus x. And already from here, you should see that this is a constant in regards to y. So given x, which means it makes that a constant value, this is constant. So that already tells you that this is uniform on this interval when you condition, okay? But if you didn't notice that, you'd keep going. So the expected value of this is, that means you put in a y for the density, integrate over y. So this is a constant that comes out. Limits of integration, we get this. And notice that that agrees with this up here, right? The mean is 1 plus x over 2. Now we have to find the x squared, expected value of y squared. So we put in y squared to the density, integrate it, we get this. Plug in the limits of integration, we get this polynomial. Now the variance is expected value of y squared given x minus the mean squared, and we plug in the values that we just got, and then that simplifies to this, which is the value that we got up here. Number 45. Let x1 through x21 be a random sample from a normal distribution with unknown mean mu and variance 1. Then LU is a lower and upper confidence interval, is a 95% confidence interval for mu. For a particular random sample, we observe x bar and find that L is equal to 10.54 and U is equal to 11.4. Which of the following statements are true? Now, number 45, it asks which of these are true. And one is the probability is 0.9 that mu will assume a value between 10.54 and 11.4. And that is false because that says that mu could be in the interval or it could not be in an interval. But that's the wrong way to think about it. Mu is a fixed value, and the interval either contains mu or the interval does not contain mu. And so anyway, so 1 is false. And then true, if we repeat this entire sampling and interval computation process 100,000 times, independent times, we would expect about 95,000 of those resulting intervals to contain the true value of mu. And that is correct. And that's actually what's called a frequentist viewpoint. If you do something long enough and with a large enough sample, you're going to be right 1 minus alpha of the time, or 95% of the time. That's what a 95% confidence interval is. And number 3, if we were to collect one additional independent observation from the same sample normal population, the probability is 0.95 that the new observation will fall in the interval 10.54 to 11.4, and that's false. It's a confidence interval for the true population mean. It has nothing to do with about individual observations. So that is false. Number 46, let x1 through xn be a random sample from a normal distribution with mean mu and variance sigma squared. Which of the following are the endpoints for a 90% confidence interval for mu? Number 46, we want to which one is the correct confidence interval. So this is the formula for confidence interval. We have a sample size 9, so this is 9. And the sample standard deviation is you take the sample variance, which is this sum of squareds thing, divided by n minus 1 square root. So that's S. And then this, with 8 degrees of freedom, is 1.86. Well, the 9 and the 8 can come out, and that's 72, and that's whatever it is. And then 2 times 36, so a 6 can come out, and then 1.86 divided by that, you get this, and so that's the answer. Number 47, let x, y be the coordinates of a point randomly chosen from the xy plane, and let r equal to the square root of x squared plus y squared be the distance from x, y to the origin. If x and y are independent, normally distributed random variables, each with mean 0 and variance sigma squared, what is the value of r such that the probability that r exceeds little r is 0.95? So 47, we want to find little r such that this probability is 0.95. Well, if we square both sides, we get this. And these are interesting because they're normal distributed. X and Y are normally distributed with mean 0, variance 1. So now, variance sigma squared. So if we take an x minus the mean divided by sigma, that's a standard normal. So if we were to square it, then it becomes a chi-squared. And x and y are independent. So if we divide everything by sigma squared, these become chi-squareds. And they're independent, so we can add them, and we get another chi-squared with 2 degrees of freedom. So then this becomes this, where w is a chi-squared. So if this interval is 0.95, that implies that this quantity is 0.1. So then, to solve for r, you multiply sigma squared up, take the square root of both sides, and you get this value. 48, the random variable x has density function f of x, which is equal to that there, where c is greater than 0 and k is between 1 and 2. What is the mode of x? Number 48, we want to find the mode, so we take the first derivative of the function. So it's the derivative, this C is a constant, so it's the derivative of the first minus 1 times the second, constant comes out front, the first times the derivative of the second, and then the chain rule we have, and that's where that minus comes in. So now I factor out an x to the k and a 1 minus x to the k minus 1 of this expression to get this. It's still equal to 0. Then I rearrange this to be this. Now we have the product of three numbers equaling 0. You set them all equal to 0. So x can be 0, x can be 1, or x can be k plus 1 over 2k plus 1. And this is the mode because 1 and 0 are not in the domain, so they can't be a possible solution. Number 49. It is hypothesized that of all marathon runners, 70% are adults, 25% are adult women, and 5% are youths. To test the hypothesis, the following data from a recent marathon are used. And there's the table. A chi-square goodness of fit test is used. What is the value of the test statistic? Number 49, we want to find the value of the chi-square test. So adult males is probability of it's adult males 0.7, probability of adult women is 0.25, probability of youth is 0.05, sample size of n. Here's our formula for our test statistic. So we start plugging in values. We get 630, and then the probability of a male is 0.7 times 1,000, it's 700, so that's 700. And we do that for women and then youths. And then we start simplifying and then simplifying, and that becomes 25. Number 50. Let x have the density function f of x equal to e raised to the x minus 2 for x less than 2. What is the 75th percentile of x? Now, problem 50, we want to find the 75th percentile. So if x is our distribution, being less than p is 0.75. And since it's continuous, it doesn't have to be equal to, but it should be. So this probability is going from p to downward, and the antiderivative of that is just itself. Plug in the limits of the limits, we get this. When we plug in negative infinity, that becomes 1 over e, and it just becomes big, 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 and goes to 0. So it's just a p. And this was 3/4 or 75, 0.75. So then take the log of both sides and then add the 2 over. You get p is equal to log of 3/4 plus 2. Now this is the last video in the sample actuarial exams, the old probability and statistics exams. I hope you've enjoyed it. It's been probably more work than I thought it would be originally, but I think it's a pretty good product for anyone wanting to study for the exam P. Well, if you liked it, click like, and now I'm going to start in on other topics, other statistical topics, and do it at a moderately, from medium to high level. So hope you enjoyed it. Thanks. Bye.